mm, the 5. So, the opening is decreasing up to the 0.05. Nagkagamay siya. Okay. Other graphing paper, this is bali siya. It is more of a bali. Others started here with the smallest diameter, then increasing to the right to the maximum diameter available. Okay, so if you have a greater number at the intersection, in decreasing at this point here, you will have a result of the curve like this. Pero if you will have a smaller diameter on this side, greater diameter on this side, you have the opposite of this curve. So you will have a plotting like that. So this one will be here, dira, ana. So ana. Because if you can, if you only have a copy of our manual, it is opposite. We'll start with the smaller and bigger on this size. So most of our plotting will be like that. Okay. Let's go back, no? Now, in our particle size distribution curve, we have these values, D75, D60, D30, D25, and D10. If, for example, you have already plotted, what if you will be asked, D60, what is the value of D60? It's more of your capability to estimate these values, no? Okay, what is this D75? That is the diameter here of the soil that corresponds to the 75%. So, dili mo magsugod diris diameter kay mo may unknown. Kaning 75 represents the percent passing. So, 75%, you project that to the curve, then upon it intersecting or touching the curve, at the point of intersection, you drop it down to the abscissa. Then, at this point, you are going to read or what you call that, approximate the diameter. So this is what you call D75. For the D60, so 60%, project to the curve, intersect, drop down. Okay. Approximate the diameter. Then the D30, 30%, same with D25, see with then D10. Now this D10, D30, and D60 are the most common diameters of percent pass at its respective percent finer, no? D10 for 10% finer, diameter for 10% finer, and your particle size distribution curve. These are used in determining the coefficients. But before we use or before we go to that, ato sa balik ta sa atong sieve analysis. Okay. If or sa atong particle size distribution curve, diha ang taganina. Now, if you have already performed that, plotted that, there are portion of this or there is a portion of the soil upon or after sieving it nga naa sa pan passing the 200 sieve. If it has passed the 200 sieve, pino na kay na. If it is pino na kaayo, more or less it could be silt, very fine silt to clay. So you can no longer, you don't have sieve for that because we only have the D200 or we only have the sieve 200. Mostly we make use of the determination, make use of hydrometer to determine the diameter of those fine particles. So that's where hydrometer analysis comes in. Muna second part, using hydrometer and the principle of sedimentation. Kana man na imo man nang ipalugdangon ang imong soil dispersed into the water with chemical on it, then ipalugdang. After palugdang, not just after palugdang, your soil dispersed in water, naa na kay hydrometer inside that that cylinder that contains the water where you have the dispersed soil in it. Okay, so in the hydrometer analysis, the particles settle at different velocities. So these are the factors to consider when you do hydrometer analysis. Ang shape, ang size, ang weight, ug ang viscosity of water. Remember, ang clay, niingon ko last meeting nga, mura na siyang flakes. Ug dili mo ka-imagine sa flakes, nga gagmay kaayo, kana galing ngayon ko nga mura na siya oats, dagko ra ng oats, gagmay pag yun ana. Oats kanang quaker oats, murag ko an. Ring ingon ko ni ko nga uli mulod anon, murag kaspa. Okay, so these are what we consider when you do or when you determine the sizes using the hydrometer. Okay, for simplicity, we use the following assumptions. All the soil particles and spheres, the velocity. So, ngano ang velocity? Kay imo mang palugdangon ang imong clay particles which are in flakes. Nya, the kusog na may uman kusog mo, settle. So, unsa iyang velocity when it settles? So, the velocity of soil particles can be expressed by Stokes' law. Now, these are the terms in Stokes' law. Okay, unsa ng V, unsa ng rho. Okay, so you have the V here is the velocity, rho S and rho W, density of soil particles. So kaning S, as I have said, solid or soil particle. Dili na kuan particle gyud, solid. Ang rho W is density of water. Then this N is the viscosity of water. D is the diameter of soil particles, which is the unknown. Okay. So in hydrometer analysis, percent finer than a given particle size D can be determined by using the hydrometer reading L. Now this time, percent finer particle size D. Now if we have the percent finer from the formula of the mechanical analysis, we have that formula, percent passing or percent finer than a given size. Given size, let's say number 200 sieve. That's what we have. But sieve with larger number than that we don't have, so that would be where this comes in. Kaning percent finer than a given particle size, which is smaller in opening than the number 200 sieve. Then the diameter here and the hydrometer reading L will be of use. You have the diameter, the L will be the vertical distance of water surface and zero gravity of hydrometer, and T is the time. Time involved here because you have to allow the particles of clay to settle. So you have to measure the time. Even the velocity when it settles, you have to use the, now in this formula we don't have the velocity but the length and the time lang. Anyway, length and time, distance that it moves from one point to another, then you time it, you can have the velocity. Then the K, which is value, there is a function of specific gravity of soil and viscosity of water. Okay, for the L, naatay mga standard values ana because this is our sieve. This is our hydrometer. Kani, we don't have a bigger cylinder, plastic cylinder man ta ni, but when if we only have the time to perform, we can, or given the time we are allowed to, we can make use of a 1000 ml nga graduated cylinder. That is the biggest cylinder that we have there, graduated. Okay, pero ang gamiton ani mostly from the other or for other people, they will use plastic, no calibration but plastic. Okay, any particles that are dispersed, this one particles that have settled. Then you have the L, distance from here, the center of gravity of your hydrometer to the water surface. Then you have, ang standard is gikan dinhi padong ani nga dimension or portion of the hydrometer. Then from there, diha. These are standard values. You have already the size of your diameter, you can measure constantly siya for a given hydrometer. But this L, no, this is what you're going to determine using the principle of measuring from this end to that end, from the bulb, tip of the bulb to here, neck of your stem of your hydrometer, then to the water surface. You have calibration. So, na lang na siya. You have the dimension here, this one, and you can only, what you can do is read, that would be L1. Then you have dimension, may nuso na nimo, you will have, you can measure, gikan padung diha, you will have the L. But we have given values for that. Okay, the value of L centimeter for the ASTM, this is ASTM 152H na hydrometer. So, standard hydrometer for the ASTM can be given by the expression L is equal to L1 plus this formula. L2 consists of L2 V sub V is volume hydrometer bulb and area cross-sectional of the sedimentation tank or cylinder. Okay. Now, more or less, measure, then you can do this by measuring and by reading R. R here is the hydrometer reading corrected for the meniscus. In the hydrometer reading, this is the reading that you have, the coincidence of the fluid surface to the calibration of the hydrometer. Mga reading dito. So, it depends more on the reading. Your reading. Now, you are given an example here, a reading of R50. Now, for L1, 10.75 cm for a reading of R equals 0. Kung 2.3 centimeters ang atong L1, for a reading of R equal to 50. So, for any reading, we can only make use of this one. They are making this as a standard value because ato mangong L1 sa hydrometer constant manggod na if you have a standard hydrometer. So, predetermined na daan ang L1 and L2, L1. Ang reading na lang, mag-agad mo sa reading for the L. Okay. Hydrometer. Okay, so you have table of variations. Sa imong hydrometer reading is this would be the L that you can to be expected. Gigaan na ta og hydrometer reading, dili kay gigaan. If for example, you have a hydrometer reading that falls on these values, you already have the L values for those respective readings. Buutan ka si baha indas. Di mo tagaag problema. Okay. So, ito siyang hydrometer. Imo sa itong i-plot. When you plot it, you have this plotting paper or graphing paper. Imong plotting, imo itong i-sumpay dire. Gagmay naman kaayo to. Yeah, remember that in the hydrometer analysis, the soil that you use there is that portion that is nasawd sa pan. That is percent or portion of kwan that passes through the number 200 sieve. Kay number 200 naman ang naa sa atong laboratory. So, itong gagmay na kaayo that pass through, mo to atong gi-subject to hydrometer analysis. When we plot it, ato itong isumpay dire. Okay, so you have the mechanical analysis by sieving, and imo isumpay dire is the hydrometer result. The plotting of the distribution curve that you continued here using the hydrometer. Okay. So we have the D60, D30 mano. What are these? They are what you call the parameters for particle size distribution curve can be used to determine these parameters. Okay. Unsa maning D10? Unsa to ning D? Diameter of 10% finer. This parameter is the diameter in the particle size distribution curve corresponding to 10% finer. the effective size. Effective size. You call this as effective size. Di nini mo basahon og D10. Effective size of a granular soil is good measure. You can make use of it to estimate the hydraulic conductivity and drainage through the soil. Okay, another name or term for hydraulic conductivity, di niya mo kasabot kaayo ang hydraulic conductivity, no? Ato na lang mong kuanan, permeability. Wala pa gali gid mo kasabot og permeability. Soil being permeable, it allows water to pass through the void spaces. Sa to'y atong assumption in the soil, I moingon ko unsay atong assumption. Now, this is the second time nga murag maka-lecture ko. This one is video, the other one was meeting. Ngayon ko, moingon ko nga ang atong soil has voids. Now, these voids are interconnected.